Hello again, folks, and welcome back to another day of Advent of Code. This is going to be day number 14. Last night's puzzle was a little bit of a number theory puzzle, and Eric does have some degree of variety, and he said that if you didn't solve yesterday's, that's fine. You'll still be able to solve future ones. So. The one thing that he did mess up yesterday they wanted to talk about is it's not actually called the Euclidean algorithm that's used here. It's the Chinese remainder theorem. And there's this really funny graph over on the Advent of Code display that is basically saying like there's a huge spike in this that was literally caused by people searching for. See, where's the Google search trend? Oh, come on. This is literally, let's see if I can find it. Top today, weird math trick goes viral, this one. Oh, I see. The reason it didn't pop was because it was spoiled. So yeah, it turns out that a heck of a lot of people, right as the puzzle dropped, looked at the Chinese remainder theorem on Google, and Google shows it to you, which is hilarious. That is... That's the main thing I wanted to share from last night is I incorrectly named the Chinese remainder theorem. But the way that I solved it was essentially a kind of more manual and tedious version that still worked for our input sizes. The other thing that I heard from other folks is that you apparently can solve this naively just by incrementing using the highest prime and looking for multiples of the highest prime, which I didn't know, but apparently you can solve it in a couple of hours if you just let the semi-naive solution run. So today I learned. The most effective way is the Chinese remainder theorem followed by what I did, which is adding the least common multiple of everything you've seen so far. Yeah, I can understand that some people were willing to let the naive solution run overnight because they went to bed and were going to sleep on it, and when they came back the next morning, they had something that worked more or less. And yeah, it is possible that people had input that was more conducive towards manual development versus doing it the kind of more smart way. Cool. Well, we've got about 2 minutes left. I'm going to go ahead and initialize my day 14. And we'll go ahead and copy this over, trim out all the other stuff as usual, and we'll see what we have in store. I suspect this probably won't be super number theory centric for the next little bit, but we'll find out. We'll kind of see how it goes and adapt based off of what we see. And if you are like slightly behind, it's fine. Like, you can either start from the most current day and work backwards, or like pick up where you left off. Honestly, I don't necessarily recommend if you get stuck in a problem like repeatedly bashing your head against the wall, do something that makes you feel good, that helps you have a sense of progress. All right. Good luck to everyone who is doing Advent of Code on their own. I'll see you whenever you finish, maybe on someone else's stream, depending upon whether you finish before or after me. So let's go ahead and take a quick break, and then we'll see you for the puzzle unlock. Hydration is super duper important. If you are not adequately hydrated, your brain will become very, very sad. Even if you hydrate and have food, though, that is not a guarantee that you are not going to feel worn down, though, because COVID brain, or not COVID isolation, like not actually having COVID in my case, but like the 9 months of isolation is starting to get to me a little bit, just a little bit. All right. We have another airport that we're coming into, so it'll be interesting to see what airplane-related puzzle Eric gives us to go back to another place rather than going directly to the island. So we'll see what that is. Yeah, I'm pretty excited. This is a weeknight, so I don't imagine it'll be too difficult, but we'll find out. Got 5 seconds left, and let's have a look at what the puzzle is. Update the bit mask or write a value to memory. Okay. So run the initialization program. Okay. That's pretty straightforward. Cool. I know exactly how to do this. So let's go ahead and paste my input. And after my scare from many nights ago, does this end in 515346? Yes, it does. Okay, write it out. All right. So we're going to parse this, splitting on the equals. So all right. So if operand is going to be parts of 1. All right. And then we need to switch either it is expected opened. Oh wait. Yeah, that'll actually work fine, but actually this should be let's just do it that way instead. All right. So we also need to keep a map of what current memory addresses are set. So that's going to be a map of int to int. How many bytes is this? This is always given as a string of 36 bits. This is always going to be int64. In fact, uint64 always. All right. If it's case memory, then we need to take parts of 0 from index 0, 1, 2, 3, 4, I believe, until index parts 0 minus 1, I think. Let's check it. Right. And then we'll just set editor. Okay. Oh wait, that's not quite correct because the mask can be a binary number, which is a very different thing. Okay, so that's fine. That goes like that. All right. So and we don't use the index number of the line. Fair enough. I'm glad you're enjoying these, Andrew SC1. Okay, that looks like it parsed fine. I am trimming one too many digits. This is why I print this, just to verify. So this is actually like that. Wait, no, that's not like that. Why does that not? Oh. Oh, I see what I did wrong. So this was fine like this, and then this needs to be. Where's my print? Print line of error. So 53, 814, that's correct. 62, 11, okay, those are all fine now. Great. So instead, so let's have a look at the rest of the puzzle now. Bit mask is always given update the bit mask or write a value to memory. Okay. So the bit mask in X leaves the existing bit mask in place. A 1 sets to 1, a 0 sets to 0. Okay. So if it tries to write 8, 0 to address 8. The value 0 is there, yep, and it overwrites, what does 1 do? I see, so the bit mask leaves the bit and the value unchanged. Oh, it's applied to values immediately before they're written to memory. Got it. Okay, great. Okay, so we need, so how shall we do this? So when we're explicitly setting bits in the mask, we wind up doing effectively is anything that is a 0 winds up, okay, I see. Okay. So initially, yeah. So instead of keeping the mask as 1 value, I'm going to set it to 2 values here. So a mask of 0, 0 of like becomes just, yeah, we'll do it this way. So this is how I'm thinking about this. Because then, in order to apply the mask, we will bitwise not and let's see, off and or with on. Okay, how do I make this go with off? So in that case, it will be what's the correct operation here? So if I want to force a bit to off, that is equivalent to doing a bitwise subtract, is it not? Delaying spec. Bitwise, so we support bitwise and or an XOR. Oh, there is a bit clear, which is and not. Great. So that is, does that work? Yeah, because that'll be anding with 1 preserves the value and anding with 0. Yep, okay. So that is, according to Go docs, that's bit clear, and that is, okay, cool. All right, I think that works. So we have case X, we have case 0 and case 1. So case X means that mask at index I, and this is always going to be so that's going to be mask on and mask off, both need to be mutated here. And we need to bitwise clear right, I think that should do it. I'm just going to handle this in a second. All right. So mask off is unaffected. Oh, that mask off needs to be cleared, but mask on needs to be, that's reversed. Okay. Yep, like that, and then we have the opposite case here. Okay, let's just print these real fast. Let's see. So format module. If I want to print it as a base 2, it's like that. Mask off, mask on. All right. Oh, and I need to specify to tell it must be a minimum of n bits. So width is specified by an optional decimal number preceding the verb, so that is going to be 36. All right, so how do I get it to proceed with 0 if needed? Not entirely sure what's happening here. All of my masks supposed to end in 0. No. Oh, I see the problem. So the reason for this is let's have a look at this. So oh, that should be 1. That's what's going on there. Thank you, Ariel. Good observation. That still isn't right. So I is going to range from 0 to 35, so I think that this is the other bug that I have. Okay, that seems better, although not great. So let's have a look at that last bit mask that I'm supposed to set. So according to that last bit mask, 1, 0, 0, x, 1, yep, 0, 1x, 0, wait, 1, x, yeah, this is the x, 0, 0, 0, string of 5 ones, yeah, that looks correct. Yeah, okay. I believe that so far, so the problem is just that this isn't printing the leading 0 on the off mask for some reason, which is fine. Okay, I think I have something that more or less works. So now we're going to do this. They're not still all ending in 0, Ariel. At least the... I think all of the... Okay, I'm just behind in my timestamps. Great. All right, so we're going to steal the debug flag here because I don't want to print the debug flag super verbosely all the way along, but this could be helpful as I look at this. So we're just going to paste this in here. All right. All right, and same deal here. Actually, I don't need that. Okay. All right, so all right. All right. So we have this. Mask on and mask off are both uint64s, so all the types should align. So uint64 operand, and then we are going to OR it with on, and then we're going to mask off it with, I don't think I need these parens, but I think that should be fine. And we want to know what is the sum of all values left in memory after it completes, so that's easy enough. For v in range memory, sum is 0, sum plus equals v. All right. Oh, well, that's fine. All right. Let's go ahead and feed it the sample input. That is a bug. All right, so 165 matches 165, therefore I'm pretty confident in this. We're going to go ahead and feed it in. And now one gold star closer, and that did not place in top 1000. That's fine. Version 2, loading bit. So we mask the result. Okay. Okay. So it doesn't modify the values being written at all. So instead, we have a slightly different problem. Okay. That is fair enough. This could potentially, given the lot of x's, I could potentially be mutating a lot of different memory locations. Oh, but this file actually is not that large. How many x's are there? Not that many. I'm pretty sure this will be fine. Okay. So for the part B logic, we still keep the same mask on, mask off logic, but instead this logic here changes. So let's go ahead and do this. All right. So not part B, then we're going to use this logic here. Otherwise, okay, destination memory address, so, okay, this is going to need to look like that instead, which is fine. let's just make sure that I didn't break it. Okay, that still looks fine. That still looks fine. Wonderful. Okay. So let's see this. We're going to need to first apply the changes to the bit mask, and then we'll need to step through and apply each combination. Okay. So the value is always going to be uint64 operand. And we need to find out how many bits are not set between either of them, and that's the number of distinct memory values we need to write. So first let's apply mask off and mask on. Wait. Oh. The corresponding bit mask address is 0. The address of bit is unchanged. Okay. Yeah. The bit. Hey, Viwu, looks like you finished before me. Congrats. So over here, so in order to find things where mask off is and mask on is 0, that's just going to be mask on they can't possibly both be 1, so I think the simple answer here is that we XOR them. Is that right? If we XOR them, 0 and 0 goes to 0 still. No, that doesn't work. Okay, so it's going to be not, it's going to be bitwise not. Okay, value set is going to be off or mask on. So gotta love your bit twiddling, Eric. That's what we gotta do here. We gotta do some bit twiddling. Glad my spouse is gonna have a field day with this because she is a C programmer, and it turns out that bitwise operations are a little bit easier in C. All right. Let's see. So, all right. So, all right. All right. Let's see. So we're going to build up the destinations from right to left. I think that's probably the correct way to do it. Yeah, okay. That makes sense to me so far. Okay. other way around. Have I considered recursion? I mean, yes, but in general, I don't actually like to do recursion that much. Yes, I know here there's a maximum of 36, but on the other hand, like, you know, I can kind of a little bit, kind of poor person's recursion here. So, all right. All right, so the original value. Hey, thanks for the raid, Nerkwala. Appreciate it. Let's see. So, if the bit mask is 1, all right. So we can just take care of that here. I think that should do it. Okay. So this is going to be a floating bit. This is going to be a floating bit if there is no value, if there is no value set at that bit. So if all right, how do we do this? So if it's floating, okay, I understand why Ariel is asking me to do recursion here. But being the stubborn person that I am going to try this without recursion, and that is fine. All right. If it is floating, take every value out of previous disks and prefix 1 and 0 to each of them. Otherwise, post prefix image at pos to each value from previous. Okay. If we have nothing, then this is our base case. If Alright, and that's going to be append both the values 1 and 0. So that's my base case. Otherwise, All right. This is finicky code. I have literally no idea whether this is going to work, but we're going to roll with it. So over here, actually this can just be encapsulated as bit is not equal to 0. That feels more logical. Okay. So over here, so it's going to be, we're prefixing it. So and that is just going to always be prefixing 0, which has no effect. So that's just going to be re. Okay. And now, okay, now we have all possible values for now we're going to do this. Oops, that's not the correct print statement. I want to take this print statement here. All right, oh, and that should be a print F here, not a print line. That's fine. Caught it before we actually ran it. Okay, that should do it. Where did I go wrong? Line 53. Oh. Yep, that's fine. And line 78. Oh, that's range. Okay, simple enough. Now I've got some errors. Line 55. So okay. That. Okay, and make uint 64. 60. Oh, this can literally be that because I'm using the append, and appending to a nil generates the new array the way we expect it to. Lastly, line 81 is broken. Oh, because this is now that. This should not be taking that long, so we have a problem here. I guess the other question I have to ask is, mathematically, is it possible that some of these bit masks line up? Because if they don't, then I can literally just, no, I do have to evaluate it. Okay, why is this not finishing? Dog. Flurry. Shush. Shush. Oh, silly dog. Okay. What's going on here? Let's run it in debug mode real fast. Okay. So I'm printing out the bit mask. Okay, so my first write is just immediately failing. I'm not actually writing anything. Why am I not actually writing anything? Probably because... where is this? One of these for loops is not completing. Let's find out whether it's... Let's find out what's going on there. Nope, we're not even getting that far. Okay, this is always the fun and exciting part of this. Curious what's happening here. Ah. Okay. So that's running, it's just taking way too long. So my first value here... Oh. I see. This is the wrong mask here. I need simple 2. Okay. That's why I'm executing it on a really weird input. So this produces the value 208, which is correct. Okay, so that was actually fine. I just had a value like in my original thing that was way too freaking big, and that therefore had way too many freaking x's. All right, so now let's try running it. Let's go ahead and take that away. Just run it on my regular input. And that's correct. Okay. So the brute force did work here. I just lost a bunch of time with trying to debug using an input that was going to be n-performant because it had a bunch of x's in it. Whereas this doesn't have too many x's, so therefore the explosion from computing the number of floatings is not very large. Okay, great. All right, I'm actually pretty happy with this. Let's just run it once with the debug so we can verify that my debug output looks fine. Yep. All right, that seems perfectly reasonable to me. Yep, looks fine. Okay. Day 14 to go. Day 14 AB solution. And we'll go ahead and push that up. And there is apparently a link in day 14 now. Let me look at that. Where's the link? Ah, bitmask. Yes. Bitmasks are, oh, in part 2. Memory address decoder. Okay, I'm not actually going to pull that up right now because I do not want a copyright strike. But yeah. Cool. Awesome. Let's go ahead and see who's still going and go ahead and raid them. Thank you for watching. And as always, my code lives at lizthegray on github.com, so feel free to check that out. And thanks for tuning in, and I'll see you all tomorrow. Looks like Irenes are going. Looks like Irenes are going.